This video briefly covers Kirchhoff's second law, which is also known as the loop law, which states that around any closed loop, the sum of the voltages must equal 0. So whenever we are circling around a portion of a circuit, we must know whether we should add or subtract voltage levels. From what we are covering in class, there are two different ways that we can gain or lose voltage in a circuit. We can either pass through a resistor or we can pass through a battery. If you are traveling with the current through a resistor, you will subtract or lose voltage, and if you are traveling against the current through a resistor, you will gain voltage or add voltage. And typically, you are not told the voltage difference across a resistor. Instead, you are given the current and the resistance of the resistor, and you will use Ohm's law to calculate the voltage difference. The reason why we subtract voltage when we travel with the current is because as the current flows through the resistor uses some of the potential energy that is stored in the charges. Therefore, the voltage level before the resistor is going to be higher than the voltage level after the resistor. So therefore, there is going to be a drop or decrease in voltage. If we are going the opposite direction of the current, we know that we are traveling from a lower to higher voltage level. Therefore, we are going to increase in voltage, so we will add the voltage difference. Next, let's talk about batteries. This is the schematic drawing for a battery, where the long end of the schematic drawing represents the positive terminal of the battery, and the short end of the schematic drawing represents the negative terminal of the battery. We are going to add the voltage difference if we are traveling from the negative to positive terminals of the battery. And we are going to subtract the voltage difference if we are traveling from the positive to negative terminals of the battery. Since batteries give potential energy to the circuit, we know that the voltage levels are going to be higher on the side of the positive terminal, and the voltage levels are going to be lower on the side of the negative terminal. Let's do an example where we want to calculate the battery's unknown voltage. So we're going to make a closed loop here that starts below the battery, travels through the battery, and through the 1,000 and 5,000 ohm resistors, and then once again back to where we started. We know that Kirchhoff's second law states that the voltage levels within a closed loop sum to 0. Since we are going from the negative to positive terminals of the battery, we are going to add the battery's voltage levels. And since we are going through the resistor with the current, we know that we must subtract the voltage drop across the 1,000 ohm resistor, and to calculate this voltage drop, we will use Ohm's law. So we're going to subtract the current, which is 0.005 amps, times the resistance, which is 1,000 ohms. And then we will travel through the next resistor, and we are still traveling with the current, so we're going to subtract the voltage difference once again, and to find this voltage difference, we're going to multiply the current, which is 0.05 amps, times the resistance, which is 5,000 ohms. And we see now that we're back to where we started, so we know that we can set this quantity equal to 0. And when we solve, we see that the battery's unknown voltage was 30 volts. You may be wondering how you know how to draw the loop, which direction you circle and which point you start from. And what's nice about Kirchhoff's law is that as long as you make a closed loop, there's no wrong approach. And to show this, we are going to make a second loop going counterclockwise, starting before the 1,000 ohm resistor, and you will see that the battery's voltage is still 30 volts. So let's begin. Since we are going against the current, we are going to add the voltage drop across the 1,000 ohm resistor. So we're going to take the current times the resistance, and we're going to add it. And now when we go through the battery, we're traveling from the positive to negative side of the terminal. So we're going to subtract the voltage drop across the battery. And when we're going through the 5,000 ohm resistor, we're once again going against the current. So we are going to add the voltage drop, or the current times the resistance. And when we solve again, we still see that this battery's voltage is 30 volts. We now have the tools to tackle more complex problems like this one, where we do not know a current, a voltage of a battery, and a resistor of a resistance. We know that we can use Kirchhoff's first law to solve for the missing current. The current going into the junction at the top is 6 amps, and the current coming out is 2 amps and our unknown current. So we can easily solve and see that this missing current was 4 amps. Next, we can solve for the battery's voltage by applying the loop law, or Kirchhoff's second law. So we're going to use this loop right here. We're going to travel from the negative to the positive terminals of the battery, so we will add 100 volts. We're going to go with the current through this 4 ohm resistor, so we're going to subtract the product of the resistance times the current, so 4 times 6. And then when we go through the 2 ohm resistor, we're still going with the current, so we're going to subtract the 2 ohm resistance times the 4 amps for the current. And then we're going from the positive to negative terminals of the battery, so we're going to subtract the battery's voltage. And when we travel through this 5 ohm resistor, we're still traveling with the current, so we're going to subtract the current times the resistance. And we set this equal to 0, and when we solve, we see that the battery's voltage is 38 volts. And lastly, we want to solve for this unknown resistance. So we're going to apply Kirchhoff's second law again, and we've made this loop here. And when we start with this loop, we know we're going with the current, so we're going to subtract this unknown resistance times the current, which is 2 amps. Then we are going to add the battery's voltage, since we're going from the negative terminal to the positive terminal. And we just solved, and we saw that that was 38 volts. And then, lastly, we know that we are going against the current through the 2 ohm resistor, so we're going to add this voltage drop, which is the current times the resistance. And we can set this equal to 0, and we see that the resistance is 23 ohms.